All right, we have the volume of a box and we want to find the extreme values. So we know to do that we're going to find the derivative, set it equal to 0 and solve for x. So what I would do first is get this in a form that's easier to take the derivatives, meaning I would multiply this stuff out. So my first step is I'm just going to distribute the x to all that good stuff in parentheses. So I get 14x minus 2x squared, and then I still have the 15 minus x. Now I'm going to distribute, FOIL this out, and so I end up with 14 times 15 to 10, and it's 14x. 14x times negative x, negative 14x squared. Now I'm to these pieces right here, so negative 2x squared times 15 minus 30x squared, and then finally negative 2x squared times negative x plus 2x cubed. From here, I'd just probably move things around. I'd put the 2x cubed up front. I would collect these two like terms and then throw my 210x at the end. Alright, I set the derivative equal to 0, so I need to find the derivative. So the derivative of this would be 6x squared, 88x plus 210. I set it equal to 0, and I solve for x. Now, the only thing that I can see that I could factor out is a 3. So I factor out a 3. That leaves me left with 3x squared minus 44x plus 105. And I could sit and try to factor this, okay? So that's what I'm trying to do, is I'm trying to sit here and say, okay, can I factor this 3x? And one of these numbers are kind of large, so it looks hard to factor. And I always tell students, and in this case, this doesn't factor nicely, is if I have a quadratic, then why not use the quadratic formula? Minus b plus or minus the square root of b squared minus 4ac over 2a. So in this case, I'm going to have a minus negative 44, because that's my b, plus or minus the square root of negative 44 squared minus 4 times my a times my c, all over 2 times my a, which is 3. And if you do the plus or minus, actually I'll do an extra step here. This works out kind of nicely because what's under the square root becomes 676, and that's actually a perfect square. That's 26 times 26. And so now I can continue with my quadratic formula, continuing meaning I can do the plus 26 over 6, and then I can do the minus 26 over 6. If you do it, this piece you're going to see is like 11.666666666. Well, one, that's outside of my domain, and now you can see why it doesn't factor. Or 3, which is inside the domain, so that's going to be my x value. So when x equals 3, I just go all the way back up here to my volume, and I plug in 3 everywhere I see an x. So 3 times 14 minus, it's a minus, come on minus, 2 times 3, and then 15 minus 3. And if you plug that in, you will see that you get the extreme value of the volume of 288. And this is certainly by the largest volume of the box occurs when x equals 3.